So, hello everyone. I am going to share my BARC interview experience. These were my favorite subjects. They asked me to write 5 subjects on the board in sequence as I am comfortable with. So, first was digital electronics. They asked me questions on counters, shift registers, and some combinational circuits, some designing part, including memory as well. So, I will tell you the questions that I remembered from each of these subjects. Uh, it will be helpful for your upcoming interview. So, the first question from digital electronics was they asked me to design a circuit that will count my interview timing in seconds, display the result in seconds. Count my interview timing and display the result in seconds. So for this I used a synchronous counter. For this I used a counter, and clock frequency I kept as 1 hertz, which means one clock pulse will represent 1 second. And they given a condition that maximum duration of your interview could be 2 hours. So choose the mode of this counter as accordingly. So in 2 hours, first I found out the number of seconds in 2 hours. That would be somewhere around 7200 seconds. So for 7200 seconds I need to select the mode. So I told them that it should be from this formula. I'll choose. So the mode or the number of flip-flops stages required would be around 13, or we can take more also. Should be greater than equals to 13 number of stages. So I told them that 13 such flip-flops will be connected in cascade, and I'll take output of all the flip-flops and give it to a 7-segment display, and it will display the timing in seconds. Then their question was, will you choose this counter to be synchronous or asynchronous? So I told I'll choose synchronous, as synchronous is faster. So they asked me how much faster. So I told uh, in async, if I'll choose asynchronous, then delays in all the cascading stages will get added up, and finally we'll get slightly shifted output. So they were interested in knowing how much the output will shift. So I told that delay is in nanosecond. So they told that your clock frequency is in hertz, and you are displaying time in seconds. So will these 13 or 14 stages, if we take even if we take 10 nanosecond delay in one stage, then 13 stages will give 130 nanosecond. So they told that is 1 second clock comparable to 130 nanoseconds. So the answer was no. So uh, actually they wanted to tell me that synchronous will require more circuitry, hence I should go for asynchronous, as here delay won't play much significant role. So this was the first question. Second question was based on they asked me to uh, initialize a flip-flop with preset and clear, depending on a person whether he's entering the room or leaving the room. It means that when a person enters the room, the flip-flop should start counting, or flip-flop should initialize preset, and when the person is leaving out the room, flip-flop should get cleared. So I use this optocoupler kind of circuit, LED and a photodetector. When the person is entering, this photodetector, uh, this signal from LED and photodetector will get cut off, and the continuous wave which is being generated at the photodetector will get a low level glitch for a short duration, and this low level glitch I used to trigger that active low preset. Then they asked me about what is active low, active high, and then subsequent questions were whether this preset and clear are synchronous or asynchronous. Preset and clear, synchronous or asynchronous. And then few questions were based on this thing only: synchronous, asynchronous, preset, clear, which one is advantageous, how can we avoid disadvantages or limitations of the other one without using the later one. And then second panel member asked me questions on analog electronics, and there the first question was design an integrator circuit and give unit step as its input. So I was designed it very easily with op amp, as we all know. Then they told me if step signal is given here, what will come here? I told ramp will come. So they told if let's say step is of 1 volt, and after 1 hour, what will be ramp here? So I told that it will go and it will saturate till VCC or minus VCC. Here in this case it will be saturating to minus VCC, as the input is given on the negative terminal. So I told them that it will saturate as per the supply. Then their question was, what if this plus minus VCC supply fails in the middle of operation? So this question I want you all to think, and if you are not getting the answer, I'll tell, you can ask me in comments below. Okay, so you have to think that what happens to an op-amp circuitry in operation when this supply suddenly trips off. What happens to the voltage? Will it suddenly falls to zero, or will it gradually falls to zero? And provide me explanation for whichever answer you choose. Okay, so let's move to next question. Next question, one question they asked me from signals and systems. In that, they asked me few questions on aliasing, sampling frequency, optimum sampling frequency we should choose for a band pass signal. They gave me a signal like this. It is not centered at 0 hertz, it was centered somewhere around 10 kilohertz. And they asked what is the ideal sampling frequency, and then they asked me to sample it and then draw the receiving circuitry of that. I mean that detector circuitry also they asked me to draw. So I did all these calculations and I designed. Then they asked me what will happen if the sampling frequency fs, uh, which is greater than twice of FM for a low pass signal, no? So they asked me what will happen if fs is just equals to twice of fm. So I told that if we are to sample this, then it will become like this. I mean, there won't be any guard band. So they told me then how to recover our original message signal from this, I mean without any guard band. So I told that ideal filters can only do this job, but since there are no ideal filters in practice, so hence we required a slight guard band. So they asked me to design a practical filter. So first they asked me to draw amplitude spectrum of a practical filter. So I did it somewhat like this. Then they asked me the value of this roll off. So I told, sir, we can take from 0 to 1. Let's take 0.1. And if here it is 10 hertz, then here it should be 11 hertz in that case. So they told me Do you even know what is the meaning of this roll off? How much order of filter you would require to provide a roll off of 0.1? So this thing you have to make sure whenever you are talking in terms of roll off, uh, you need to choose the roll off so that it should be practically realizable. This much roll off will take us to somewhere around 9th or 10th order of filter, which is very complex circuitry. So this thing one you have to take care. Yeah, and one more question was from digital electronics. It was like this. They asked me what is the output current of a D flip-flop. So I told it's somewhere in the range of milliampere, depending on the logic family, whether it is TTL, ECL, or whatever. So every logic family has its own current and voltage ranges. So they told me to connect this D flip-flop with a load resistance. So I connected it like this. Then they asked why you chosen 1 kilo ohm resistor. Why not 1 mega ohm or 1 ohm? So I told that kilo ohms are easy to fabricate on IC, as all the semiconductors only turn into resistances, and on IC kilo ohms are generally preferred because it takes lesser space. So they told then 1 mega ohm is not realizable. So I told no sir, it is realizable, but it will be difficult to fabricate. So they told that uh, let's say I am having 1 mega ohm resistor, so connect that resistor here. So I connected it, I made it 1 mega ohm. Then they asked what will be the current. So if this Q is 1, so I told uh, let's suppose it to be 5 milliampere. Then they asked me to change this load resistance from 1 mega ohm to 1 ohm, and then they asked now what will be the current. So as the resistance is decreasing by 10 power 6 times, so ideally current should raise by 10 power 6 times, but 5 milliampere current can't go to 5 kiloampere, as all these are low power circuit. They work on 5 volts 12 volts, so they can't give this much big amount of current. So their point was like on what factor this output current of any flip-flop depending, whether it is depending on this load, or whether it is depending on the state, or whether it is depending on the internal logic family. I mean, if TTL is there, then it won't give 5 milliamp. It won't give current above 5 milliampere for logic level 1. So if it is depending on the logic family, then they wanted to know whether the voltage at this point will be fixed in case of logic levels 1 or 0 or not. So this question also I want you guys to think. And one question was based on fan out from this thing only. Like they told that if 5 milliampere current is coming, or uh, if you are saying that 5 milliampere constantly will come and it can't increase beyond. So this means you are claiming that mm voltage at this point is variable. Voltage at this point is variable. Then only if we are varying load, then current is remaining constant. So if voltage at this point is variable, so they were asking that how many subsequent circuits can you drive from this voltage? If your answer is like depending on the input voltage levels of the subsequent uh, flip-flops or subsequent circuits, I'll be able to make a choice that how many I can drive. But their counter question was if uh, if you are not change if the current you are not changing current, then he was saying like this, something like this, like there's a D flip flop and there's output voltage, and they were saying if this is constant 5 volt and you are saying that some current is coming 5 milliampere from here, then why don't we do like this, uh, multiple circuits in parallel? Everyone will get a 5 volt at their input. So I told that these currents will divide and they need a definite amount of current also to provide the logic levels to subsequent stages. So they wanted to know that whether these subsequent stages, input and output logic states, depending on this voltage or the incoming current. So this question also you guys think. I'll tell you answers of all these questions, but that won't be useful as you. I assume that if you are watching this video, you are going to appear in the interview. So I am just giving you a thought process which you should develop now in order to perform well there. So that's why I'm not telling the answers, but you can discuss in the comments. And if I feel that you guys are stuck, then I will help you out. And there were some questions from network theory as well. They asked me, they given me a RLC circuit, and they told that given a step input is provided here, and they asked me to explain the working without writing any mathematical equation. How will this R, L, and C behave when this step is applied to it? So it's simple if you know that control system basics, that uh, the response could be underdamped, overdamped, critically damped. So it all depends on these RLC values what we are applying. But uh, this was just the start of the question. After that, they told that take this as ramp input. Then I told that this system will become unstable for a ramp input. So they wanted me to plot the time response of that unstable system. So it would be somewhere increasing also, and like this sinusoidal variation and exponentially increasing also. They wanted to know the exact plot. So you should be aware of such RLC combination circuits. They're working especially. They won't be interested in mathematical modeling, as if you have reached till interview, then they know that you know mathematics very well. So they just want to know the conceptual clarity if you are having it or not. And one more thing they asked, they told me to energize a relay with the help of a BJT. Like there was, they told there is a high power circuit, and there's a switch, but I can't directly turn on this switch as this high power circuit will show spark. So I have to use this BJT, and they provided a relay also. I have to use this BJT and relay to as a switch to energize this high power circuit. So this configuration they were asking that in which mode you will operate BJT, and on what position of BJT will you connect this relay, and how will be the connections and all. So one question was based on this, and one question was like there are two boards, board A and board B, and we have to perform data transmission from board A to board B, and we don't have any antenna or any kind of things. So how will we transmit data? We just have a set of parallel wires and few digital circuits we can use, but we don't have any wireless transmission circuit. So this question was based on application of shift registers. So this thing also they asked. One more question was there on magnetic coupling. They had given me a transformer circuit. In this, there was one primary loop and two secondary loops. And in this secondary loops, in one loop there was a resistor connected. I don't remember the exact circuit, and another loop there was R also, C also. Then they given some excitation on this terminal, and then they were asking how will be the current waveform of this loop, how will be the current waveform of this loop, and voltages across. So all these voltages across all these elements. So they asked me to draw waveform for each current and each voltage, and then they were doing saying like what if now this supply is disconnected, how will this waveforms go, or what if this supply is reversed suddenly, if the supply is taking a 180-degree phase shift, what will happen to the waveforms. So all these questions you should be having a good clarity. There was one question from analog electronics, in that they asked that you have to build a rectifier circuit which is able to rectify a signal of 1 microvolt. So I used a precision rectifier. Then they asked me to do some changes in this precision rectifier so that it is able to provide me a waveform like this. In first half, it should give me the same as input. In second, it is giving me a square. Then again this, then again square. So it is based on combination of precision rectifier as well as op amp in open loop, we can say, or a Schmitt trigger also you can say, and then we have to add with the waveforms. So there was a waveform manipulation question like this. Then there was another practical question on energy meter. They wanted to know whether I am aware of the working about the working of this energy meter, which is used in our homes for electricity bill calculation, unit calculation, and all. So they were asking the working principle behind this energy meter and what are other applications with same principle. So this questions also. There were few questions on control system. One I told that ramp response of a second order system. They asked step response, ramp responses. They asked me to draw transient as well as steady state plots. Then they did some manipulation in pole and zero location. There were one question on when to use RH and when to use Nyquist. Will they both give same stability? Then why are these different stability methods are there? Root locus, Nyquist plot, polar plot. Why can't we use one generalized method that is suitable, applicable for all the kind of system? And one question was where this Nyquist plot and Nyquist plots and polar plot, all these things get failed, in what kind of system they fail. And one question was on state space. They have given me a circuit and they asked me to write the system matrix of that. That is very easy. And there was one practical question that they asked to measure the temperature of this room and use a suitable controller to control that temperature within certain limit. For example, if the room temperature is 27 degree, so it should not go beyond 29 degree and it should not go below 25 degree. So in this range only I have to oscillate. So they were asking that which controller selection will you make here and all.